Well, are we going to be stuck with plain, simple sine and cosine functions all our lives? No, we could do a whole bunch of things to these sine and cosine functions. And that's the cool thing about this. As a matter of fact, if we're dealing with a beautiful little sine function that looks like this, you know and I know it's got its positive arc part, it's got its negative arc part. It's, of course, our crest and our trough. That's right. Now, remember, this guy cycles between 1 and -1. Have you ever noticed that? This is a graph of y equals to the sine of x. Now, what we're going to look at here is we're going to look at something called the amplitude here. Well, what does the amplitude mean? In other words, the amplitude, oh, I just happen to have it written here, is the maximum vertical distance from the center line. Now, you're probably saying, what are you talking about? Look, notice how this is like a center. This guy has an arc here, this guy has a trough here, and they're actually the same distance. That's 1, and that's -1, of course. So in other words, from here to here, right here to here, that is what we call our amplitude. And our amplitude here would be of 1. See how that works? But you're probably saying, well, where does that incorporated into our formula? Well, that's actually right up here. Because if you think about it, you don't have to put a 1 in front. We all know that the number up front is 1. Oh my goodness, so that's actually our amplitude? Yeah, so you know what's really cool? Is that's where we're going to put our amplitude for every one of these sinusoidal functions that we're going to make bigger or smaller, which of course we refer to as our stretch vertically. Oh my goodness. So there's our vertical stretch factor. Oh my goodness. And that is determined by the amplitude. Now you see why the amplitude is so important. So what is this? How do we figure this out? Well, the way we're going to do it is the amplitude will be determined by the center line. We have to figure out the center line every single time. And if we can figure out the center line, there's no problem figuring out the amplitude. We can just look right on the graph and just count it. Case in point, check this out. Look at this. Here's a beautiful, beautiful little graph. Right here, look. There's our highest point, which is 10. There's our lowest point, which is -10. We know for a fact that our center is going to be 0. But how do we figure out this? How do we figure it out? Easy. It's the average between our maximum and minimum values. Look, here's our maximum value, 10. Here's our minimum value, -10. All you got to do is just like an average in math, just add the two numbers together, divide by 2. For example, let's say you get 80% in one test, 90% in another. Add them together, divide by 2. You know the average is 85. Well, there you go. You just figured out your average. Good for you. You got honors. In this case, look, 10 and -10 give you 0 over 2, which is 0. There's our center line right at 0. So if that's our center line, check out how easy it is to figure out the amplitude. It's the vertical distance to the highest point or to the lowest point. I'm going to show you. Look, A equals to 10. How do I know? It's gone up to 10. So if you think about this particular graph, whatever kind of graph it is, and it looks a little bit like a sine function, but I don't think so because it's not curved. But this, whatever the function would be, would have a 10 stretch factor in front of it. So even if it was something like a sine function, there's the amplitude of 10. Now, how about this -1 then? Why don't we call this a -10? Well, surprisingly enough, amplitude, we're always going to deal with the absolute value of it. So this looks like it's -10, deal with the absolute value, that's 10. Why do we deal with the absolute value? Because you know and I know we have a cycle up and a cycle down of it. And that cycle down is built right into the formula. So that's why we look at this as a positive value for now. Now, let's keep on going. That's positive value, remember, is for now. Okay? It might change. Hang on. Okay. Now, let's look at this particular question. Look at this. Again, we have to find the average of our max and min. Okay. So look, there's our max at 6. There's our min at -2. So add them up. 6 plus -2. Average of 2 scores. 6 plus -2 looks like 4, divided by 2 looks like 2. And if you actually put in right at 2 our center line, check how this actually divides the graph right in half. And from here to here, you can figure out what's the amplitude. Look at this. From 2 to 6, you have an amplitude of 4. Wild, isn't it? Look, if you don't believe me, you can even go from here and go down. But remember, this is, again, the absolute value. So we're going from 2 to -2, which is a value of -4. Absolute value, it's 4. So where does the stretch factor go? Just like always, that stretch factor goes up front. It is a vertical stretch factor, and we even refer to it as A not just being the A value, but A now referring to the amplitude. And it's really important that we always put the amplitude being positive. Why? Because if we put a negative here, check out what happens. You know that the sine function starts with an uphill kind of look to it. If we put a negative, don't forget, that's a reflection now, which means this guy is flipped. Oh my, look at that. Okay, so that's now a reflection if we put a negative in there. Aha. Now, interesting to look at. A for the sine value, no problem. A for the cosine value, no problem. But I'm going to show you right now that the A for the tangent has really no amplitude. I know we're not going to look at tangent yet. We will in subsequent podcasts. Stay tuned. Put this one on the back burner. Okay? Now, a couple more things we have to remember. The amplitude then we know is the vertical stretch factor about the x-axis. Yes, it's how much are we going to stretch this guy up this way. So we got a nice, beautiful stretch going from here to here. See what I mean? And this value could be anything. It could be 30. So if that's 30 and this is our center line, that means down here, this has got to be minus 30. But you notice something? Did you notice? We didn't talk about the period at all. The period in this particular case is still 2 pi because remember, this is a vertical stretch. We have not stretched this thing horizontally at all. So the period remains the same, still a 2 pi. It takes 2 pi to go up and down, do one complete circuit. That's really important to remember as well. Okay, so now let's take a look at some really cool questions. You ready? Here we go. So I've got a couple questions I want to ask you, and this is it. Look, for example, if I gave you something like y equals to 3 sine x, you know and I know that this has an amplitude of 3. Look at this one, case in point. This is a -5 cosine x. This has an amplitude of 5, but don't forget with this negative here, this means that we're going to have a vertical reflection over the what? You got it, the x-axis. Ah, interesting. Okay, so instead of having a cup going this way now, we're going to have a cup going this way now. Oh, isn't that interesting? You betcha. We're going to get into that right away. Okay, so if A is greater than 0, we got a vertical stretch by a factor of A, but if A is less than 0, we have it reflected and vertically stretched by a factor of A, just like this one dealt with us. Okay, remember folks, remember, so important to stretch the graph vertically by a factor of A means to multiply all of the y values of each of the points of the graph of A. So what are we talking about here? Yes, we are in fact talking about a mapping. You betcha. There's the vertical stretch. Oh my goodness. And of course, last but not least, finding the amplitude is really, really simple. If I gave you the values and I didn't give you the formula to figure it out, if I said, here are the values, tell me, what is the amplitude? Very similar to finding the midpoint. The only difference is, think about it, the only difference is a difference. When finding the center line, okay, the center line, whoops, can't spell, the center line, make that look like an N, okay, the center line, you have a max plus a min over 2, center, there we go. Boy, that's terrible looking. Divided by 2. But to find the actual amplitude now, all you have to do is take the max and subtract the min and divide it by 2. And that'll actually give you your amplitude. Don't believe me? Watch. Let's go back to this question here. I'm going to go to this guy. I want to find the amplitude. We know the amplitude is 4. Take the max, subtract the min, divided by 2. Okay, 6 minus a minus 2 means plus, right? So this is going to be 8 over 2, and lo and behold, look at our amplitude. Our amplitude is in fact 4. See how it works? All right, so there's a bunch of formulas. All of those formulas you should know how to do, and just throw them onto your formula sheet right now, and then eventually you'll be so good at it you won't even need to look back on your formula sheet. You'll just do it.